Okay, so good morning, all of you. In the last session, we discussed about the energy sources and its types. Oh, 1 minute, please. Okay, so the energy source is a two-terminal element that supplies that energy to the circuit. Is there? Is it right? Now, actually, there are two types of energy sources are available. One is a voltage source. This is a symbol. Other is a current source. And voltage source having its two types: ideal voltage source and the real voltage source. When I say that ideal, so you have to consider that this is the imaginary concept is that, and the real is nothing but the physically concept is that. The current source, this is the symbol of a current source, and again the current source has its two types: ideal current source and the real current source. Let's have a discussion about one by one. First, voltage source. This is a symbol of a voltage source is there. The first type of a voltage source is a ideal voltage source, and then we will try to discuss that why that ideal voltage source is also known as constant voltage source is there. So the reason is that ideal voltage source is one which will maintain the constant terminal voltage no matter how much current is drawn from it. Means the voltage source which will always have a constant terminal voltage. Current flowing through that voltage source, it may be anything, but the voltage is always constant. That's why this voltage source or this ideal voltage source is also known as a constant voltage source. This is the basic reason. I think I have given that the 2 or 3 examples to understand this concept. If you see that this is one simple circuit, here we use that ideal voltage source of a 5 volt which is connected to the 10 ohm resistance. We know that the ideal voltage source will maintain the constant voltage. It means that the voltage across the 10 ohm resistance is a 5 volt. The current may be anything. Now here in this case current is a 0.5 ampere. Another one example, here now I consider that ideal voltage source is over 10 volt. It means that it will maintain the constant voltage across the 5 ohm resistance, which is nothing but 10 volt. The current is anything is that. Is it right? And another one example I have given. Let me try to draw that example also, so that once again your concept about that ideal will be clear. So here let me try to draw that another one ideal voltage source. So suppose I consider that this is the ideal voltage source having a value of 5 volt. This is a positive terminal, this is a negative terminal. And now in the first case we have connected 10 ohm resistance. Now let me try to connect 20 ohm resistance here. This is a 20 ohm resistance. Is it right? Now as we assume that this is ideal, it means that the voltage in between the two terminal A and B is always constant, and this A and B is connected to the 20 ohm. So can you give me that how much is the voltage across this 20 ohm resistance? It's a 5 volt.
5 volt.
Is it right? मग आता तुम्ही हे पहिले एक्झाम्पल आणि हे तिसरे एक्झाम्पल कम्पेअर करा. पहिल्या एक्झाम्पल मध्ये आयडियल व्होल्टेज सोर्स हा 5 व्होल्ट होता. आता या एक्झाम्पल मध्ये सुद्धा आयडियल व्होल्टेज सोर्स 5 व्होल्ट आहे. या केस मध्ये रेजिस्टन्स हा 10 ओम होता. या केस मध्ये रेजिस्टन्स ओम आहे. म्हणजे रेजिस्टन्सची व्हॅल्यू तुम्ही कोणती घ्या, त्याच्या अक्रॉस जे ते आयडियल व्होल्टेज सोर्सच येत आहे, 5 व्होल्टच येत आहे. करंट वेगवेगळा, कारण तुम्हाला 0.5 करंट किती येऊ शकतो बघा, कॅल्क्युलेटर V divided by R 0.25
हा 25
सॉरी एम्पियर. म्हणजे तुमच्या हे लक्षात असेल आयडियल व्होल्टेज सेम आहे, रेजिस्टन्स वेगवेगळे असू शकतात, त्यातून फ्लो होणारा करंट वेगवेगळा असू शकतो, पण त्याच्या अक्रॉस जे व्होल्टेज आहे ते कॉन्स्टंटच आहे. That's why it is called as a constant voltage source. Get clear? But this is the imaginary concept. Let me clear that. Because when we consider that any voltage source, it has its own resistance, and that resistance we call its internal resistance. Is it right? And here, in the case of an ideal voltage source, we consider that internal resistance is zero. That's why it is possible. What is possible? The constant voltage is developed across the load resistance, whatever it may be, the value of a load resistance is there. Try to read this point. Let me remove that the written part so that you can easily read that point. Is it right? An ideal voltage source has a zero internal resistance. This is the basic reason behind why that ideal voltage source maintain the constant voltage across the terminal. Because ideal voltage source has a zero internal resistance. Therefore, it would provide constant terminal voltage regardless of the value of a load connected to it. Is it right? So up to this much, I think we have discussed the previous things. Now we will talk about the actual voltage source exists मध्ये असतो त्याच्याबद्दल आपण डिस्कस करू. आयडियल व्होल्टेज सोर्सच्या बाबतीमध्ये आपण बघितलं की इंटरनल रेजिस्टन्स झिरो आहे, त्याच्यामुळे कॉन्स्टंट व्होल्टेज डेव्हलप करतोय. परंतु रिअल व्होल्टेज सोर्सच्या बाबतीमध्ये इंटरनल रेजिस्टन्स झिरो नसतो. इट हॅज इट्स अ फायनाइट व्हॅल्यू ऑफ इंटरनल रेजिस्टन्स. आता इंटरनल रेजिस्टन्स म्हणजे काय? जो त्या व्होल्टेज सोर्स प्रेझेंट. And it is that when we use actual voltage source, definitely we have to consider its internal resistance also. But when I want to draw the diagram of a real voltage source, how I can show the internal resistance inside that voltage source? Quite difficult thing is that. Is it right? That's why diagrammatically, when you want to represent real voltage source, so then you can represent internal resistance which is connected in a series with that voltage source. In this is the ideal voltage source, and when I want to draw the diagram, actually the internal resistance, let me clear that, is present inside the voltage source. But when I want to show in a diagrammatically, then I can show that internal resistance in series with voltage source is there, and the A and B is there. आता आयडियल व्होल्टेजच्या आपण डायग्राम बघितलं तर इंटरनल रेजिस्टन्स हा दाखवलेला नाहीये, कारण इंटरनल रेजिस्टन्स आपण काय म्हणतो? झिरो म्हणतो. म्हणून तो टर्मिनल व्होल्टेज काय करतो? कॉन्स्टंट प्रोव्हाइड करतो. आता इथं इंटरनल मध्ये आलेला आहे, त्यामुळे व्होल्टेज ए आणि बी हे वेगवेगळे असू शकतात. बिकॉज दिस इज द रिअल व्होल्टेज सोर्स. दिस इज द डिफरन्स बिटवीन आयडियल व्होल्टेज सोर्स अँड द रिअल व्होल्टेज सोर्स. या ए आणि बी मध्ये तुम्ही व्हॅल्यू किती व्हॅल्यू रेजिस्टन्स कनेक्ट करताय त्याच्यावरती त्याचं व्होल्टेज डिपेंड्स राहत आहे. हाऊ? लेट मी ट्राय टू शो दिस थिंग. But the one thing is that towards how one can represent the real voltage source. मग तुम्हाला real voltage source थोडेसे वेगळ्या विचारायचा झाला तर तुम्ही असा पण लिहू शकता. Let me try to draw it here. Here I can see that this is ideal source and this is internal resistance and this is the A, and so I say that this is resistance and the ideal source V. Is it right? मग आता तुम्ही असं समजून कन्फ्युजन होऊ देऊ नका की इंटरनल रेजिस्टन्स हा कायम निगेटिव्ह टर्मिनललाच कनेक्ट केलेला आहे, पॉझिटिव्ह टर्मिनलला कनेक्ट केलेला नाही. इट्स नॉट लाईक दॅट. ट्राय टू कन्सिडर, लेट मी ट्राय टू ड्रॉ इट हियर. इफ यू ट्राय टू ड्रॉ इंटरनल रेजिस्टन्स, this point, okay, this is the positive terminal, this is the negative and the internal. मग आता मी पॉझिटिव्ह टर्मिनलला कनेक्ट केलेला आहे. Only the basic thing is that internal resistance must be connected in a series with that voltage source. Finish. Do you agree with me? Yes or no?
Yes, sir.
Okay. The another point is that, let me clear that. Do you know that the concept of a series? Otherwise, I already use that word. Internal resistance is connected in series with that voltage. It means that I consider that you must know that how to connect in a series word, meaning of the series word. Otherwise, it's quite difficult to understand this concept is there. Are you clear my point? Does anybody don't know that the series concept? Okay, it means that everyone know about the series. It means that my work is very easy. Is it right? So this is about the real voltage source, and now we will see that here what I have written. The real voltage source can be represented as an ideal voltage source in series with the resistance equal to its internal resistance. Now let's we see that example here. I have written that some points about that the internal resistance. A real voltage source has a finite value of internal resistance and it can be represented in series with that ideal voltage source. We discussed this thing here. Okay. Okay. Now, if I want to show these things, let me try to take that the one slide and then I try to solve that the one example here. Okay. Now please concentrate here. Here we have considered one simple diagram of a real voltage source. See that this is an ideal voltage source, and when it is connected in series with its internal resistance, so this is called as a real voltage source. These are the two terminals of a real voltage source. It's a value voltage V, and this is our integer divide. Okay. Okay. Now we can connect any value of a load in between the terminal A and B. Let's we consider that. Suppose I consider that here voltage is of 5 resistance is of 2 and between the point A and B I say a one value of resistance and it had its value of 3 ohm. Now if you see that these 2 ohm and the 3 ohm are connected in series, so that actually the load resistance of this entire circuit, total resistance of that circuit, it becomes 3 plus 2, which is equal to 5. Is it right? It means total resistance is of 5 ohm, total volt is 2 volt. Is it right? So then it becomes V divided by R total, which is 5 divided by 2, that R is equal to 1. Is it right? It means in this circuit the is of 1 ampere. Okay. 1 ampere current flows through this 3 ohm resistance. Can you calculate that how much is the voltage across the 3 ohm resistance? If the current is 1 ampere, resistance is of 3 ohm. So can I say that voltage across this 3 ohm resistor is 3 volt? 2. It becomes 2. Current is 1 ampere. So if I want to calculate that voltage, IR, this is the formula. Is it right? So that I is 1, resistance is of 3, so that the voltage across this 3 ohm resistance is a 3 volt. But what is that actual voltage? Actual voltage is a 5 volt. In case of ideal voltage source, the total 5 volt is appear across this entire load resistance is there. But in case of real voltage source, the sum voltage drop is across that internal, and the voltage drop, it means that 3 volt is appear across this the load resistance. This is the basic difference between ideal and the real is that. म्हणजे आयडियलच्या बाबतीमध्ये जर बोलायचं झालं तर सगळंच्या सगळं व्होल्टेज हे 2 टर्मिनलच्या अक्रॉस येत होतं, परंतु रियल व्होल्टेज सोर्सच्या बाबतीमध्ये जर सांगायचं झालं तर नॉट ऑल द व्होल्टेज विल बी अवेलेबल अक्रॉस द 2 टर्मिनल्स ए अँड बी. द व्होल्टेज इज ऑलवेज लेस दॅन द टोटल व्होल्टेज इज दॅट. म्हणून तर इथं तुम्हाला 5 व्होल्ट मिळालेलं नाहीये, इथं तुम्हाला किती व्होल्ट मिळालं? 3 व्होल्ट मिळालं. म्हणजे 2 व्होल्टेजचा ड्रॉप हा त्या व्होल्टेज एनर्जी व्होल्टेज सोर्स मध्येच झालेला आहे. परंतु आयडियलच्या बाबतीमध्ये तसं होतं का? नव्हतं. दॅट इज द बेसिक डिफरन्स बिटवीन द आयडियल अँड द रियल व्होल्टेज सोर्स. आर यू क्लिअर माय पॉइंट? येस ऑर नो?
Yes, sir.
Okay. आता let me announce here, those students are not getting how this 3 volt is calculated, what is the series circuit. So definitely our next point is a series and parallel circuit is there. When I try to explain the series and parallel circuit concept, and when you will once again observe these videos or these slides related to the ideal voltage source and the real voltage source, definitely your concept will be more clear. Because right now I have not explained the series circuit concept and the parallel circuit concept. I have assumed that you know about the series and parallel circuit. That's why I will not explain. But when this part is over, definitely I will take that the series and parallel circuit concept. And once this part will be clear, and when you will read the theory related to the ideal and the real voltage source, definitely your concept will be more clear. I will give that assurance about it. Are you clear my point? Okay. So let's go to that. The next concept, that is nothing but the current source. This is the second type of energy source is there. As you know that this current source is also having its two types. One is an ideal current source and another one is a real current source. But as I already told you, when I say that the ideal means you have to assume that this is the imaginary concept. फक्त imagine केलेला concept आहे. There is no physical existence is there. Is it right? Now we know that it's a symbol. In the symbol, I say that one circle, in that arrow, and this arrow represents the direction of a current flow, and from which point the current it starts its journey, that point we consider as a positive terminal, and at what point the current it will return, that point is we call it a negative terminal. So this is the positive terminal of a current source. Let me assume that a point A, and this is the negative terminal of a current source, we call it a point B. So these are again just like a voltage source, the current source is also the two terminal device, A and B. And now it is our duty to connect the load in between the point A and B. But as I say that this is an ideal current source, it means that this current source is also, we have to consider imaginary concept is there. And why it is called as a constant current source? Because whatever may be the load resistance connected in between the point A and B, this current source will supply the constant current in between the point A and B. That's why it is called as a constant current source. But physically it is not possible. Physically it is not possible. So try to read that. These are the two terminals of ideal current source. Read that the definition. An ideal current source is a one which will supply same current to any resistance connected across its terminal. म्हणजे A आणि B मध्ये कोणताही रेजिस्टन्स कनेक्ट करा, it will always supply the same current. म्हणजे A आणि B मध्ये सपोज तुम्ही 5 ओहमचा रेजिस्टन्स कनेक्ट केला, किंवा 10 ओहमचा रेजिस्टन्स कनेक्ट केला, किंवा 15 ओहमचा रेजिस्टन्स कनेक्ट केला, तर ते कुठलाही रेजिस्टन्स कनेक्ट केला तरी या करंट सोर्सची जेवढी व्हॅल्यू आहे, सपोज या करंट सोर्सची व्हॅल्यू 2 एम्पियर आहे, मग तुम्ही 2 ओहमचा रेजिस्टन्स कनेक्ट करा ए आणि बी मध्ये, तुम्ही 5 ओहमचा रेजिस्टन्स कनेक्ट केला, तुम्ही 10 ओहमचा रेजिस्टन्स कनेक्ट करा, त्या प्रत्येक रेजिस्टरला 2 एम्पियर करंट फ्लो होणार. इट मीन्स that the current for each resistance connected in between the point A and B is the same. That's why this ideal current source, we call it a constant current source. We call it a constant current source. But the difference is that ideal voltage source, we call it a zero internal resistance. But the ideal current source, we call it a infinite internal resistance. And we know that the basic property of a current always consider, or current always take the least resistance path. मग जर मला सांगा इनफायनाइट इंटरनल रेजिस्टन्स असेल तर तो करंट तो इंटरनल रेजिस्टन्सचा पाथ घेणार आहे का? Absolutely no. Is it right? It means that ideal current source has a infinite internal resistance. This is the basic reason why the ideal current source will provide the constant current in between the point A and B is that. This is the major difference between that voltage source and the current source. Ideal voltage source has a zero internal resistance, and ideal current source has a infinite internal resistance. That's why both the energy sources will provide the constant sources. Get it my point? Now let's consider about this ideal current source and its uh, load resistance here. Here I consider that ideal current source is of 2 ampere and a 10 ohm resistance is connected across it. So how much is the current will flow through that 10 ohm resistance? Definitely it's 2 ampere. Is it right? Now when the 2 ampere current it will flow through this 10 ohm resistance, how much is the voltage developed across that 10 ohm resistance? Current is of 2 ampere, resistance is of 10 ohm. Definitely the voltage developed across the it becomes 20 volt. Is it right? Now let's consider that another one example. आम्ही तोच करंट सोर्स आयडियल करंट सोर्स घेतला 2 एंपियर, परंतु आता 10 ओमच्या ऐवजी मी किती रेजिस्टन्स घेतलाय 20 ओम घेतलाय. आता सांगा किती करंट फ्लो होईल? 2 ampere, because it is ideal. It no matter the resistance value is connected in between the point A and B, it will always provide constant current. That's why it is called as a constant current source. म्हणजे या दुसऱ्या सर्किट मध्ये जर आपण रेजिस्टन्स चेंज केला तरी करंटची व्हॅल्यू चेंज होणार नाही. आणि इज इट पॉसिबल प्रॅक्टिकली? No. So 2 ampere will flow and the voltage developed across this 20 ohm resistance it becomes by applying Ohm's law I into R into 20 which becomes 40 volt. मग आता तुम्ही या दोन्ही डायग्रामचा कंपॅरेटिव्हली स्टडी केला. केसमध्ये आयडियल करंट सोर्स सेम आहे 2 एंपियर, परंतु लोड रेजिस्टन्सची व्हॅल्यू डिफरंट आहे. व्हॅल्यू डिफरंट असते हा करंट सेम आहे कारण हा आयडियल करंट सोर्स आहे. म्हणजे करंटची व्हॅल्यू तिथं सेम असणार. Voltage developed the load may be different, but the current through the load is always the same, it's always a constant. That's why current source is also known as the constant source. And the source internal resistance हा infinite आहे. मग infinite resistance current कधीच घेणार नाही. That is removed. Are you clear my point? Therefore, current source will not be resistant at terminals. So this is about the ideal current source is there. मग आता तुम्ही compare करा. आयडियल व्होल्टेज सोर्स काय करत होता? कॉन्स्टंट व्होल्टेज. मग करंटची व्हॅल्यू डिफरंट असली तरी चालेल, रेजिस्टन्सची डिफरंट असली तरी चालेल, परंतु व्होल्टेज काय कॉन्स्टंट राहत होता. आयडियल कॉन्स्टंट करंट देतोय म्हणजे व्होल्टेज येऊ शकते, रेजिस्टन्स डिफरंट येऊ शकते. दॅट इज द बेसिक डिफरन्स इन आयडियल व्होल्टेज अँड आयडियल करंट सोर्स इज देयर. आर यू क्लियर माय पॉइंट? नाउ लेट्स हॅव अ डिस्कशन अबाउट द रियल करंट सोर्स. आता जर रियल व्होल्टेज सोर्सच्या बाबतीमध्ये आपण बघितलं की इंटरनल रेजिस्टन्स पिक्चर मध्ये येत होता आणि तो इंटरनल रेजिस्टन्स त्या व्होल्टेज सोर्सच्या सिरीज मध्ये आपण रिप्रेझेंट करत होतो. आता रियल करंट सोर्स, as we know that current is always divided in a parallel circuit. That's why when we consider the real current source, definitely the internal resistance comes into picture. But the thing is different is that when I want to represent internal resistance of a real current source, it can be represented in a parallel with that current source is there. Just see that. This is the ideal current source, and when I want to show the internal resistance of this current source, definitely we have to connect diagrammatically. I can represent that internal resistance of a real current source is in a parallel with that current source is there. This is the basic difference between real voltage source and the real current source is there. Right. आता प्रश्न असा तुमच्या मनामध्ये येतो की सर तुम्ही व्होल्टेज सोर्सच्या बाबतीमध्ये इंटरनल रेजिस्टन्स दाखवताय सिरीज मध्ये आणि रियल करंट सोर्सच्या बाबतीमध्ये तुम्ही इंटरनल रेजिस्टन्स दाखवताय पॅरलल मध्ये. काय बेसिक हे कशामुळं? तर मे बी तुम्हाला पॅरलल आणि सिरीज सर्किटचा कन्सेप्ट जर लक्षात येत असेल, you can remember that the voltage can be divided in a series circuit only and the current can be divided in a parallel circuit only. This is the basic reason the internal resistance of a voltage source is always represented in a series and internal resistance of a current source is always represented in a parallel. Are you clear my point? So that's why you have to remember comparatively internal current source is always presented in a parallel with that current source is there. And the reason that's why the current source will not maintain the constant current because current will taken the path of the internal resistance is there. Are you clear? Real current source has internal resistance. म्हणजे हा त्याच्या real source ला internal resistance therefore according to load resistance. A real current source has an ideal internal resistance. The entire diagram present with this in here. If I want to start this entire diagram is called as a real current source is there, and the two terminals of the real current source A and B is there, where we can connect the load resistance depends upon our requirement is there. Okay, so just consider that this is an ideal current source. When I want a real current source means internal resistance comes into picture, and we know that the basic theory, when I want to connect that internal resistance to this ideal current source, I can connect to in a parallel. This is the internal resistance is there. Is it right? And now this is a load resistance area, which is between the point A and B is there. Now you can, if the current, let me try another here. Okay, the pen is not actually working. Then also I try to draw it here. If I say that this is the source, this is the instance of source. These are the current source position A. So this entire diagram we call it a real current source. Because we have real current source. Okay. Now, when I say that one resistance of an ohm is connected in between the point A and B. Now, just when this 2 ampere current, it starts its journey from positive terminal, it flows this direction. When it comes to this point, what happens? Some part of current will take a path of 2 ohm resistance, and another part of a current will take a path of a 10 ohm resistance. Is it right? Is that due to internal resistance, not all current will take a path of 10 ohm resistance. Some part of a current will take a path of a 2 ohm resistance. That is the reason the real current source will not maintain the constant current or will not flow the constant current in between the terminal A and B, because some part of a current it flows to the internal resistance part is there. But ideal current source मध्ये काय होतं? Ideal current source मध्ये हा 2 ओहमचा रेजिस्टन्स हा इनफायनाइट होता, मॅक्सिमम होता. आणि आपल्याला माहित आहे व्हॉट इज द बेसिक प्रॉपर्टी ऑफ अ करंट. करंट ऑलवेज टेक द लिस्ट रेजिस्टन्स पाथ. जर तो मॅक्सिमम रेजिस्टन्स असेल, इंटरनल रेजिस्टन्स असेल, तर डेफिनेटली हा 2 एम्पियर करंट हा मॅक्सिमम रेजिस्टन्सचा पाथ घेणार नाही, तो कायम 10 ओहम मधूनच फ्लो होणार. and that is why the ideal current source will maintain the constant current flow. Are you clear my point? Yes or no? Okay, so don't worry about it. I think it's my inner voice says to me that some students are not properly understand due to the series and parallel circuit concept. But let me clear that once this part is over, I will try to cover that the series and parallel circuit concept. And once this part is clear, then definitely once again we will try to have the revision on the this voltage source and the current source. And when we take the revision of this part, that time you will feel like that this part is very easy. Is there? Is it right? So let's we go to that next point. That is nothing but the source conversion. For solving the examples, we must have the knowledge about the source conversion is there. Now, source conversion means what? Till now we discussed that the real voltage source and the real current source. So sometimes we need to convert that voltage source into current source and the current source into the voltage source. So what is the procedure? That things today we are trying to discuss here. So let's we consider that real voltage source to the रियल करंट सोर्स. आता ज्यावेळेस रियल कन्सेप्ट, आता इमॅजिनरी कन्सेप्ट सोडून द्या. आता मला पहिल्यांदा एक गोष्ट क्लिअर करा की रियल व्होल्टेज सोर्स म्हणलं की तुमच्या लक्षामध्ये काय यायला पाहिजे? व्होल्टेज सोर्स इन सिरीज विथ इट्स इंटरनल रेजिस्टन्स. इज इट राईट? आणि रियल करंट सोर्स म्हणलं तर तुमच्या काय लक्षात यायला पाहिजे, करंट सोर्स इन पॅरल विथ इट्स इंटरनल रेजिस्टन्स. ओनली सिंपल these things you need to understand. Is it right? Now see that what is the procedure here. This is a real voltage source. आता जर तुम्ही ही डायग्राम व्यवस्थित बघितली तर तुमच्या हे लक्षात येईल की हा व्होल्टेज सोर्स आहे, हा त्याच्या सेरीजमध्ये इंटरनल रेजिस्टन्स आहे आणि हे त्याचे दोन टर्मिनल ए आहेत. That real voltage source we have to convert it into real current source. मग आता तुम्ही जर डायग्राम व्यवस्थित बघितली तर तुमच्या लक्षात येईल हा करंट सोर्स आहे, त्याच्या पॅरल मध्ये हा त्याचा इंटरनल रेजिस्टन्स आहे आणि त्याच्याशी हे दोन टर्मिनल आहे. Now what is the procedure actually? The procedure is so simple, just we have to apply that current source. Sorry, we have to apply that Ohm's law. Means what? The procedure is like that. If we want to convert real voltage source into real current source, the first procedure is that the internal resistance of voltage source same as the internal resistance of a current source. म्हणजे जर इंटरनल व्होल्टेज इंटरनल रेजिस्टन्सची व्हॅल्यू व्होल्टेज सोर्सच्या 2 ओम असेल तर रियल करंट सोर्स सुद्धा 2 ओम असेल. पण अँटी करंट सोर्स I apply that Ohm's law, you have that value of a voltage, you have that value of internal resistance, we give by R internal is the value of a current. So simple thing is that. See that what is the procedure? The procedure is that calculate the value of current source. आता आपल्याला we have to put it into is given. Is it right? That the current source I is R or R internal. Is it right? And the second thing is that internal resistance of current source same as voltage source is that only to connect in a path. These are the 2 steps. The procedure is there to convert the voltage source to real current source is there. Let's we have check that the numerical here. This is voltage source. This is the internal resistance of voltage source series, and now we have to put it into current source. See that internal resistance same as the internal resistance of current. Difference is that it is connected in parallel. We can get value of I by applying the Ohm's law R into R internally. This is the simple thing. Just consider the example. The 10 volts are this. The in series is the internal resistance source. These are the terminal of 10 ohm resistance is connected in between them. We have to put this entire circuit into a real current source. How can I it? This is current source. This is a positive source. This is a positive terminal. This is a current source. Call it a point B. Now this is internal resistance. Give me that. What is the internal resistance current source? The internal resistance of a current source is a 2 ohm. So what is the value of a current source? For that we apply that the Ohm's law. I equal to by R internal within 2 is loaded into the real current. This is one of the example of real voltage source, real current source. Get it, my point. Now you can connect this 10 ohm resistance in between, no doubt. Okay. Now we will try to see that current source to voltage source. आता इथं करंट सोर्सचा सिम्बॉल आहे, त्याचा इंटरनल रेजिस्टन्स पॅरलल मध्ये कनेक्ट 2 टर्मिनल आणि तो आपल्याला वाटत आहे रियल व्होल्टेज सोर्स मध्ये व्होल्टेज सोर्स दिसेल which is connected to the resistance 2 terminal. Now the procedure is again same. What is same? Internal resistance of a current source same as the internal resistance of a voltage source, but the difference is that we have to connect series. Voltage source resistance हा time series मध्ये दाखवला जातो. How to calculate that value of a voltage source? Apply the you have the value of current source, you have value of its internal resistance. Then so the first procedure is calculate voltage is equal to I into internal resistance. Right? And second step is internal voltage connected in a so here it's my mistake that connected in a series, and then connect the load resistance between the terms A and B as it is. Let's see that example so that your concept will be clear. The real current source we have to check into real voltage source. आता voltage ला resistance हा series मध्ये जातो. The thing is that apply V is equal to I internal. See that example. Suppose I is along with the load resistance having a of here. It's an internal resistance 2 ohm and load resistance connecting the point A and B is a 10 ohm. And now we put into real voltage source. When I say that real voltage source, it is a voltage source in series with the internal resistance and the other 2 terminals of the real voltage source. Now, what is the internal resistance of this source? Yes, please. What is the internal resistance of the source?
10 ohm.
It's a 2 ohm. Voltage source असणार आहे म्हणजे internal resistance voltage source, internal resistance current source is the remain same always. But the how this voltage source apply the I into internal resistance into 2, which is becomes 10 volt. Resistance आपण कुठं संबंध नाही. Is it right? We want it is all connected with the having the constant value of the internal resistance, value of voltage and internal resistance. Are you clear this point? Are you clear? Yes or no? Okay. So this is about the real voltage and real current source. So it's my request to all the students. I think first time you are learning this concept, the voltage source, current source, and it's my request to all of you, try to see the videos. I will try to share that the PPT 2 times, 3 times, up to you will understand this concept. Clear point. And still, if you have that the problem, then you can ask me the problem related to voltage and current source. I will try to explain. And from next lecture onwards, definitely I am the concept of important concept. I request to all of you to don't miss the lecture. Very important concept about the series and the parallel DC circuit. You make from branches. You make from branches. So these parallel circuits are very important. All the right? So up here.